All right, guys, I'm back again. This time we're going to be looking at ordering real numbers, more specifically comparing irrational numbers. Now, I'm going to start off with this video because I believe that this one is probably going to be the simpler of the two. Once I get into actually putting irrationals or real numbers in order, that one is probably going to be a little bit more challenging. But again, not anything that is terribly difficult. Okay, so let's go ahead and go ahead and move over to our comparisons. Now, when you look at this, you might say to yourself, what in the world is this? Okay, now all that it's saying is that we are comparing the square root of 3 plus a number 2 to the square root of 3 plus a number 3. Now, in this particular case, what we're going to do is we're going to use or rely a little bit on our common sense. This is a form that was made for me by one of my super artistic students. We know that the square root of 3 is actually not listed here. There's no perfect square for 3. So what I know is that if I have an x value, say that value is 1. If I multiply x squared, 1 by itself, that's going to be 1. The square root of x squared is going to get me back to x. Now, what did that mean? We're just trying to find the square root of 1. The square root of 1 is going to be 1. Square root of 4 is going to be 2. Square root of 9, 3, so on and so forth. Now, where would the square root of 3 fall in this list? Because it's actually not listed here. So it's going to fall somewhere between here. So the square root of 2 and 3 would fall between here. So therefore, some number between 1 and 2 squared is going to be the square root of 3. But again, we're going to rely a little bit on common sense here. If I know that I'm comparing the square root of 3 on each side, this number, whatever that value is going to add the same amount to whatever this number is, the same amount to whatever that number is. So for instance, I do know that the square root of 3, we're going to estimate that to be, because it falls between here and here. I know that the number falls somewhere between here and here. So what we do is we just take the mean, also known as the average of 1 and 2. The mean of 1 and 2 is going to be 1.5. So I'm going to add 1.5 plus 2. Make my comparison 1.5 plus 3. Okay, so I want to go back over that one more time. Okay, so I know again that since the square root of 3 falls between the square root of 1 and 4, so 2 and 3 fall between here, I know then that the square root is also going to fall somewhere in there. What I'm doing is I'm just taking an average of 1 and 2, and that's going to give me a good approximation. It's not exact. It's just going to give me an approximation. And keep in mind that that'll lend itself toward the video that is coming up. Okay? So, back here, 1.5 plus 2 is going to give me 3.5. 1.5 plus 3 is going to give me 4.5. So when I look at that, I want you to go ahead and pause the video, take a little bit of time to think about what that comparison is, and then start me back up when you're ready. All right, I assume that you have an answer now. So at this point, we know that 3.5, is it greater than, less than, or equal to? I know that 3.5 is less than 4.5. It's just that simple. Okay. Now, we're going to move into one that's a little bit more difficult. We actually have to use a little bit more brain power. Okay, and I'm going to refer again back to my handy-dandy list. I'm trying to find the square root of 11. It does not appear in this list. So, okay, so 11 does not have a perfect square. Okay, so where is that going to fall? It's going to fall somewhere between 9 and 16. So I know again that my square root is going to fall somewhere between 3 and 4. Now, the best approximation basically is just to take the number 3 and 4, add those up. That gives you 7. 7 divided by 2 will give me the average, also known as the mean. We're going to use the mean. Okay, but if you're a parent watching, you know average, but mathematically we call that the mean. So 3 and 4, add 3 and 4 together. That's going to be 7. 7 divided by 2 is going to give me 3.5. So my best approximation for the square root of 11 is going to be 3.5. plus 15. I'm going to make this comparison. Back to my chart. Where does the square root of 8 fall? The square root of 8 falls in here, so 5, the square root of 5, the square root of 6, the square root of 7, and the square root of 8 falls somewhere in there between. Again, my approximation is going to fall somewhere in there as well. 2 and 3 is 5. 5 divided by 2 is going to be 2.5. 2.5 plus 15 is going to give me what? 18.5 and 17.5. What's my comparison? I know that 18.5 is going to be greater than. Now, again, there's a little bit of common sense involved here as well, because I knew that I had the exact same constant. I knew that this number is going to be larger, therefore it's going to yield a larger square root. So more than likely it was going to be here. I didn't want to tip you off at the beginning, but that's the common sense way of comparing them as well. We're going to look at one last problem. Square root of 7 plus 2 compared to the square root of 10 minus 1. Sorry about that. We had a little bit of technical issues, which I was able to take care of in the editing. All right, so back to what we were doing. The square root of 7 plus 2 compared to the square root of 10 minus 1. Okay, so some common sense might be available here, but let's go ahead and use it according to this method. We know that the square root of 7 is going to, again, fall where? It's going to fall somewhere in here. My approximation, 3 plus 2, 5. 5 divided by 2 is going to be 2.5. So let's go ahead and approximate that to be about 2.5. The square root of 10, again, will fall between 9 and the square root of 9 and the square root of 16. It's going to fall somewhere in there. So my approximation, 3 plus 4, 7. 7 divided by 2 is going to be 3.5. So my best approximation is 3.5 minus 1. Okay. And I go ahead and add these together. 3.5 minus 1 is 2.5. So again, my response is to say that 4.5 is greater than 2.5. It is just that simple with comparing your irrationals. As always, if you have additional questions, please ask me in class. Come to tutorials on Tuesday and Thursday. And I hope that this video was informative for you. If not, watch it back again. And again, if you don't get it still, I am here for you. And as always, I will see you in class tomorrow.